Makes me tired.
I am
All right.
completing a part.
Ratio test. This test is particularly useful for series that converge rapidly, such as factorials or exponentials. So it has 3 conditions on it, very similar to the 3 conditions on the second test, the root test, to kind of help you remember all of them. If the limit of a sub n plus 1 over a sub n is less than 1, then the series converges. If your limit is greater than 1, it diverges. And finally, if the limit happens to equal exactly 1, inconclusive. Okay. The key to using this test is actually going to be algebra and being able to separate your exponentials and factorials properly so that you can reduce it. It's basically large versions of fractions. This is why it's called the ratio test. It's not like overly difficult at all. It's just learning to separate them out. So in our first example, we have e to the n over n factorial. Can you agree that this would be a difficult one to kind of eyeball? I mean, factorial is always increasing, but like e to the n also increases pretty quickly. And you can't we're going to guess it converges probably because we said the factorial just goes so quickly. However, you have to be able to show that. So here is how you do this. The first one, I'm going to show you the original setup of double fractions, but just like the one we did, the limit comparison test, we immediately went to flipping the double fraction. We'll do that here too, okay? So you would set up the limit as n approaches infinity of the a sub n plus 1 term. So look, anywhere we have an n, they put in n plus 1 over the a sub n original term. Any issue with that setup based off of our definition?
Why is it not, or why is the example 1a sub n plus 1 and this one good?
So it's a sub n plus 1 because that's the notation to say the n plus 1 term. So that's like saying a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, and so on. A sub n is the nth term. So the way to notate the n plus 1 term of any series is a sub n plus 1, but it just means any n's in your equations change to n plus 1s. That's all that means. All right, so we set that up. Now, obviously, we do not leave ourselves double fractions, yes? You do outer over inner or keep change flip or whatever you want to call that. And we look at our limit with 2 fractions here, okay? Now, absolute value on this, the way it was in the definition, is only necessary when we're looking at alternating terms, right? Or something that has a negative in it. So we don't worry about it if we don't have anything that needs to be absolute valued. From here, it becomes a matter of taking your exponentials into pieces and your factorials into pieces. So we get factorials when it's 5 factorial, because we're oh great, 5 times 4 times 3 times 2 times 1. But what you really have to do on these is think about what n plus 1 factorial means. And now I really don't want you to have to write this out every time, but just to think about it the first time, n plus 1 factorial really means n plus 1 times what?
In factorial.
The next one down would be just what?
In factorial.
N, and then n minus 1, and then n minus 2, and then n minus 3, and so on, right? So couldn't you just say, I could split the n plus 1 factorial into n plus 1 times n factorial? Because n factorial would take this and all the terms down, right? How can you then think about splitting the e to the n plus 1? We've talked about that a little bit. Yeah, that's going to be e to the n times e to the first. Okay. And the reason we break it into those pieces is because you want to watch out for these other pieces, the smaller ones that you have, and we want to cancel anything that we can. So that's why we break it into those pieces. We look at that and we say, she just goes straight to canceling. I'm going to write this out for you, okay? This would be written better as E, the limit, as n approaches infinity. I'm going to write this as e to the n times e. I'm going to write the denominator as n plus 1 times n factorial so that I can see what cancels. I'm going to be able to cancel an e sub n top and bottom. What else am I going to be able to cancel? N factorial top and bottom. Now, why does that actually help me? What am I left with? An e on top. This has no n's. What is e? Just a what? Just a constant. So now I'm really just doing the limit as n approaches infinity of e over just n plus 1, right? That's all I have left. What is that limit going to be? 0. Is that greater than 1, less than 1, or equal to 1? Less than 1. Therefore, because this is less than 1, what do we know? Okay, it converges. Questions about that? All right, so let's try that again with the next one. Again, we have powers of an exponential. It might be hard to say that exponential on bottom combined with the n cubed, is that going to be enough to make it converge? I don't know. I'm not real sure. So I'm going to set up this new ratio test. We're going to set it up. Now I got to skip through our canceling that I already did on mine. Okay, here we go. It's fine. All right, we're going to set up our ratio test. Now, this one, like I told you, goes straight to flipping the second fraction. So remember, to get your a sub n plus 1 term, each n changes to an n plus 1. So we've got 3 to the n plus 1. We've got n plus 1 all cubed. And we've got 2 to the n plus 2 because we combine like terms. Yes? Then we just take the second part of it and flip it so that we don't have to show a zillion steps. Now, what would be helpful to us to kind of break into pieces? Yeah, I'm going to take my 3 to the n plus 1, and how am I going to write it? 3 to the n times, what? 3. What else do I need to break down here? Yeah, the bigger one, the 2 to the n plus 2. Now, they're not always going to be the same exact thing, so how do I break that one down? What would be the next term down? 1 less than that one. How do we write this? What's the only way I can take this apart for exponentials?
2 to the n times 2 to the 2.
Okay, you can take it initially into 2 to the n times 2 to the second, yeah? We okay with that? Because that's just taking the plus sign and breaking it into 2. Now, does that actually help me? I mean, I can break this down too, right? Nothing's saying I don't have to. Can I break it down differently? Could I take one of these 2's and put it over with this one to make it an n plus 1? Isn't it also okay to say that's 2 to the n plus 1 times 2 to the first? Why is that okay? Because if I keep my bases and I add my exponents, don't I still get n plus 2? These are both ways to break that down. It just depends on which one you want. Which one's better for us? 2 to the n plus 1, right? Because, what does it allow us to do? Cancel, 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 cancel. Yes? All right, so what are we then left with?
3n to the third over n plus 1 cubed times 2.
Yes. So, we you would be left with that on the bottom, yes? Is this something that we can then take the limit as n approaches infinity with? Yeah, how? Bobobot and HDC, we're back to that because this is back to a cubic, right? So I don't have exponentials. I don't have factorials anymore. All of that's gone. I have a 3n squared on top. I have a 3n cubed on top and a 2n cubed on bottom. Therefore, this works out to 3 halves, which happens to be what? Greater than 1. Therefore, we diverge. Questions about that? What will take practice, again, is like it's not the calculus rule of it. It's the breaking the exponentials and factorials down for some of us. That will take a minute to practice. Okay? All right. On the back page, we are going to be talking about the root test as I erase my extra stuff. The root test works particularly well for series involving, what does that say? That doesn't look right. Involving nth powers. That's somewhere missing on my thing here. Oops, it's on the next one. There we go. Series involving nth powers such as e to the n, e to the 2n, or any, it says n over n plus 1. It's basically anything in a parentheses raised to the n. Okay. Now, can you see how this kind of follows similar rules to the ratio test? The ratio test has us set up a sub n plus 1 over a sub n, and then says if it's less than 1, it does this, greater than 1, this. This one has us take the nth root of the a sub n term, okay? So if that limit is less than 1, can we guess? Same as the last one, converges. If that limit is greater than 1, what does the series do? Diverges. If it equals 1, inconclusive. No. Yeah. Then we'll just do 2 examples on this one. Take a minute, make sure you have that filled in. Thank you. Good job. All right. So, on example 1. This is a great example of one that this test would apply to. Everything is being raised to some power of n. Okay. Again, I might not want to guess at whether e to the 2n increases faster or 5 to the n increases faster. I mean, who really knows? So on this one, we set up our nth root test. So the nth root test says you are going to take the limit as n approaches infinity of the nth root of e to the 2n over 5 to the n. So let's see what happens. What is an nth root going to do to this? Now, I kind of need to think about that e to the 2n a little bit differently. I might want to think about it as e squared then raised to the nth power. Because what's the nth root going to do to each of these? Cancel out the nth power, right? So I'm going to have the limit as n approaches infinity of just e squared over 5. Do I even have anywhere to plug in infinity here? No. So what's this limit going to be? E squared over 5. Now, is that going to be greater than 1? Well, what's E? E is 2.7 something, close to 3. If I square it, we're going to get close to 9. Doesn't really matter exactly what we're getting. Is that larger than 1? Yeah. That's going to be greater than 1. Okay? Because that is greater than 1, what do we know? This diverges. So,
Yeah, I'm confused how that works.
well, so any power Think about roots this way.
Because like when you screw root something,
Mhm.
a cube or something, there's a root that actually you just do 1/3.
Like the reason when we're solving for like if I had x squared equals 9, the reason we use a square root on that is because it does what? Cancels the squared, right?
Yeah.
So if it's a second root, it cancels out a 2 power. If it's a cube root, it cancels out a cubed power. If it's a fourth root, it cancels out a fourth power, and so on. So, yeah, that should have an n right here too.
Yeah.
That just got lost in the notation.
What
Yeah.
would happen if there's not an n to cancel out? Like if it's e to the 2n over 5 to the root n.
You could still do that on the bottom because you could just say the nth root of 5. That would probably raise a problem though, because that would be like an infinite root, which would be making it probably pretty close to 0.
No, because if you multiply by numbers less than 0.
What about a fraction?
Yeah, they get smaller when you multiply.
We'd have to think about that. I don't know if they would do that. But
It's gotta be more.
the second example here is a very straightforward something all raised to the nth power. It kind of doesn't matter what the something on the inside is. It matters that it's all raised to the nth power. So we would set up the limit as n approaches infinity of the nth root of that whole thing. And like we just said, what's going to happen with an nth root and the nth power? Cancel. So aren't you really then just doing the limit of the fraction on the inside? So what applies again? Boba button needs DC. Back to that. Exponents are the same. Divide your coefficients. We end up with 1/2. What does that tell me? That is what? It's a converge because it's less than 1. Okay? Less than 1. All right. That was our last.